So in this session, we'll talk about event-driven architecture. Okay, so what is event-driven architecture? Event-driven architecture is a software development approach in which services or operations of software are triggered by events. Okay, and it is made up of decoupled single-purpose event processing component that asynchronously receive and process events. So this pattern orchestrates the behavior around the production, detection, and consumption of all the events along with the response they evoke. Okay, so the events along with the response uh, you know uh, they evoke. So the event-driven architecture style consists of two topologies. So mediator and broker. So the mediator used when multiple steps are needed to be orchestrated within a event bus through a central mediator. On the other hand, broker is used to chain events together without using a central mediator. Okay. So generally, a good example that uses event-driven architecture is e-commerce site. So the event-driven architecture enables the e-commerce website to react to various sources at a time of high demand. Simultaneously, it avoids any crash of the application, any over provisioning of resources. Okay, so we have two very popular queuing systems. Uh, for event driven model. One is Kafka and the other one is RabbitMQ. So both are powerful, mature, and well maintained tools with a broad support from the industry. Okay, so let me go to the another architecture pattern. So microkernel. So this architecture pattern consists of two types of components: a core system and a uh, plugin modules. Okay. So while the core system works on minimal functionality to keep the system operational, the plugin modules are independent components with specialized processing. Okay. If we take a business application perspective, the core system can be defined as general business logic without custom code for special cases. So special cases, special rules, or complex conditional processes. On the other hand, the plugin modules are meant to enhance the core system in order to produce additional business capabilities. Okay, so this is what. We are just going through the overview on the architecture, but in detail, we will maybe in the coming sessions we'll go in detail one by one. So the next one is microservices. Everyone knows. So hugely, most of the organizations, all the organizations, almost they are using microservices to avoid monolithic applications, because earlier we used to have monolithic applications, and after this service oriented approach, so we moved to microservices. Okay, so my microservices architecture consists of group of small chunks, means small services, independent and self-contained services with small code base. So unlike with the monolithic application, using a layered architecture pattern, keeping a small separate code bases can minimize the number of dependencies. So this is a most widely used pattern where generally we to avoid this monolithic architecture. Okay, so the next one we'll talk about cloud native architecture. So cloud native architecture is a software approach for building, deploying, and maintaining modern applications in cloud environment. Okay, so if we have three cloud native architectures: Amazon Web Service, Microsoft Azure, and Google Cloud. So AWS is most widely used cloud computing platform available today. AWS provides a mix of infrastructure as a service, platform as a service, software as a service. Okay, so if you see here in the diagram, right, we have all the services which, based on that we have very good art diagram. So here we have UI and we have API gateway and application service, DB and all that. So nowadays, AWS is providing everything. We just need to, grab the service and use it. That's all. Okay. So when it comes to Azure, Microsoft Azure, so Microsoft Azure architecture comes with breakdown of data flow. Okay, an explanation of individual components and potential use cases. Each architecture also includes a performance analysis based on five of uh, five pillars of the Microsoft well architected framework. Like as everyone know, not only in Azure but even in AWS also, these five pillars they generally consider for well architected framework like reliability, security, cost optimization, operational excellence, performance efficiency. So if it comes to reliability, the ability of system to recover from failures and continue to function. Okay. When it comes to security, production of applications and data from the threats. Okay. Cost optimization, management of cost to maximize the value. Operational excellence, like operational excellence that keep a system running in production. Performance efficiency, the ability of system to adapt to change in the load. Okay, so same way, like this is Microsoft architecture design. So we have database, we have users, and we have all the services, like for Kubernetes for creating services, and we have function apps, functions. So like how we have Lambda functions in AWS, like we have Azure functions. Same way, storage is S3 in AWS and here S3. So, and there's a queuing system. So we just need to use as per our requirement. Okay. So the same way we have Google Cloud GCP. Google Cloud is a collection of cloud computing service and it's a third largest IaaS provider. Okay, and Microsoft Azure is second, but Google Cloud is the third one. So third uh, cloud largest IaaS provider. So this is like I don't think so it is visible, but let me drag it down. Okay, so we have the Google Cloud. This is Google Cloud architecture. We have our end user and load balancing. We have content, dynamic content, static content, and all that. Like we just need to architect well architect by using that five pillars. What I have just now thought about. Okay, this is like what about the software architecture. Now it's time to understand design patterns. But for now, I'll just go through one design pattern, and maybe in the next sessions, what I'll do, we'll go through a coding and then do the design pattern parallelly. So the first design pattern which I'm going to talk about, solid principles. This is the excellent and well used. Most of the developers they use in every application. So this is a basic coding standard which we need to follow when we are writing any project. Okay, so let's talk about this solid principles design pattern. Uh, so what is solid principle? Uh, so S stands for single responsibility principle, and O stands for open close principle, L stands for LISCO substitution principle, and we have I stands for integration segregation principle. So we have dependency inversion principle, DIP. So what we have to do is we have to understand this this details very thoroughly. Otherwise, you'll not understand how to do this. How to implement this design patterns in our applications. Okay. So generally, the solid principles. So most generally, what we'll do, we as a architecture, we go through Gang of Four, document to understand all the design patterns. But the same way, even for now also, that is the best document. So solid, so single responsibility principle. So the single responsibility principle states that a class is having a single responsibility. Okay, so each service should have a single objective. Okay, so I'll explain, like when we are doing the coding, right? I'll explain in detail. And open close principle. So the software model should be dependent and expandable. Okay, so open for uh, extension and closed for modification. Open closed principle generally. And Lisco principle. So Lisco substitution principle. So independent service should be able to communicate and substitute each other. Okay, so this is also one of the you know most important principle. So Lisco principle states that interfaces should be substitutable and that subclasses should be replaceable for their main classes. Okay, so and there is one more. The other one is integration interface segregation. This principle states that interfaces should be broken down into smaller, more autonomous parts for the purpose of minimizing code errors and repetitions. Okay, um, so interface generally will should be divided into such microservices. There should be not be any redundancy. Okay, and the other principle is dependency injection, dependency inversion. So here, according to the dependency inversion principle, low level modules can easily get swapped out for other low level modules without high level modules being affected. Okay, so this is also one of the most used, but right now, real time, most of the people, they are using this dependency inversion principle. So we are inverting uh, things to the client, so that he will take the decision instead of we do the things. So dependency injection, or dependency inversion principle. Dependency injection is the actual implementation, but dependency inversion is the principle. Okay, so no, anyways, I'm going to give a clear detailed session on this by doing some code examples. Thank you for now.